Hello and welcome to another Tyrrell's Classic Workshop. Today we're talking about a car which is an automotive icon. I don't like using that expression particularly because it's so watered down and so hackneyed nowadays that an icon can almost be a packet of crisps really. But this is an automotive icon. It's the Mercedes 300 SL Gullwing. And it's quite interesting because this was considered one of the first supercars. There are several contenders that can be the first supercar. The Stewart's Bearcat, the Mercedes SSK in the 1920s, and the British motoring journalist Leonard Wright coined the phrase supercar, talking about the Lamborghini Miura. We've actually just got a Miura here, which we just finished, and I couldn't resist from mischief parking it next to the car which potentially is another of the original supercar contenders, the Merc. And I don't know how often it is that we have two examples of potentially the first supercar stood next to each other in the same room at the same time, but we've managed to do it today. Anyway, back to the Merc. In 1951, Mercedes decided that they were going to go racing again. They'd had a fantastic career in the 1930s, the Silver Arrows along with Auto Union. And what they decided to do was they looked at the cars that they already had in production and said, well, we got some great machinery that we're churning out here. Can we adapt any of it into bits for a racing car? And the car they looked at was the Mercedes 300. Great big, very luxurious saloon. In fact, as a model, it was called the Adenauer after the German Chancellor who loved them. So they looked at the engine from the Adenauer, they looked at the front and rear suspension. The chassis was a great big heavy clunky rolling frame type setup which was not really suitable at all. But they took the engine, front axle and rear axle, and they sort of put them on the floor and said, okay, what can we build around this? And they came up with a very complicated space frame, as it's called, which is made up of a series of bicycle tubes, basically. 25 millimeters outside diameter, 1 millimeter wall thickness. And these subframes, Lamborghini used the same on the Countach. Lots of car manufacturers have used subframe technology over the years. But Mercedes were one of the first to do it seriously in a production car. And it's just these thin tubes which are designed in such a way that they are never subject to bending. It's always either compression or tension that work on the tubes. And that's why they're so incredibly strong if they're triangulated and worked out. And that's what Mercs did. But as a result of that, you come up with a very strange concoction. So they took the engine in the Adenauer. The Adenauer is a big saloon, a big sedan, as I say, so it's got a tall bonnet, tall hood that you can hide the engine under. They wanted maximum aerodynamic efficiency. So what they did was they took the Adenauer engine and canted it over 50 degrees from the vertical this way. So it's a slanting, straight six-cylinder engine. And that worked. The only problem was, again, to keep the bonnet height down, you have a great big oil sump at the bottom, which keeps the engine oil in. It's splashing around as the car's accelerating, braking, cornering. So they got rid of that, and they put a much smaller sump on to again lower the engine height, and had what's called a dry sump lubrication system with the oil tank in this front wing, under this front wing here. Three advantages to dry sump lubrication. First one is it keeps the engine oil cool because it's always remote from the engine. Secondly, there isn't any surge from sort of the oil pump picking up oil splashing about, so you're always guaranteed a good oil supply from the remote tank. And thirdly, it tends to keep it cool as well. It tends to keep the oil cool. So let's take a first glimpse at this car. The reason why it gets its name, Gullwing or Papillon in France, butterfly, is because of the doors. And these are absolutely beautifully engineered. Everything on this car is one of the reasons why Mercedes-Benz has such a strong brand value and very strong engineering ethos today. This was one of the cars, a handful of cars that really built Mercedes-Benz reputation in the day, which still carries through. And these doors are one of the examples, beautifully counterbalanced, just lovely, and then eventually clunk. You can't buy that noise. That comes through proper engineering. And you end up with this very high door sill here, And the reason for that is because in order for the space frame to be as strong and as light as possible, they actually built the frame so as high as this along here to give it strength in the middle. And they had to really build the body, hang the body around that. Hence the fact you end up with the Gullwing doors. Clever solution to a problem, because this car was conceived as an uncompromising racing car in the early 1950s. And consequently, things like this didn't really matter. The fact that you had to climb in and out of it rather awkwardly comes with the territory. Make it as light as possible, make it as strong as possible, and that's what they went for. And they didn't really envisage this being a production car. They originally just developed it in 1952. It was Rudolf Uhlenhaut, who was extremely senior. He was the chief engineer at Mercedes, and he was also a very fine driver. He came up with this for Mercedes to annihilate the competition, which they did. And eventually, Max Hoffmann, the Mercedes importer for the US, said to them, "We need something fantastic from you. We need something that's going to really hit the headlines." And they said, "Well, we've got this." And he said, "Okay, I'm going to underwrite an order for 1,000 of these now. I can sell as many as come off the boat." That's how this car got turned into a production car. So they did very little to the car. They added some bits and pieces to it. They knocked a few things around, tried to make it as comfortable as possible. They came up with the folding steering wheel to help you get in and out of the thing. And they even came up with some fitted luggage, because there's no boot space, it's taken up by the spare wheel. So they tried to turn it into a GT car, which they succeeded in doing. But this thing was still incredibly fast for a 1950s car. They offered 3 different gear ratios for the differential in this car, 3 final drive ratios. So you could have a low-geared drivetrain for acceleration, or you could have a high-geared drivetrain for maximum speed. And in 1954, these could pull over 160 miles an hour with the tallest gearing. That was sensational back then. It really was, and it's just a testament to how well these things were done by Mercedes. It's where they got to. They weren't intending to end the journey that way, but that's where they ended up, and we can all be thankful for that. Needless to say, Mercedes blew their brains out budget-wise on this car. And when it was new, it was $13,000 in the US. So what Mercedes had to do was ratchet back some of the options list. So some of the exotic elements of the car, they actually made extra cost optional extras and tried to make the car more mainstream or standard in other ways to save money. Perfect example of this is the wheels. These wheels are an optional extra on the 300 SL. They're called Rudge wheels, after the British company Rudge Whitworth. And these obviously have spinners that you knock on or knock off to tighten the wheel up. Single spline in the middle, no bolts. Mercedes originally intended all 300 SLs to have Rudge wheels. That's the way they designed them. And then they backpedaled and used ordinary 5-bolt steel wheels with the aluminium cast outers to try and cut costs and make them more conventional. So most 300 SLs have got the tin wheel covers on them and the ordinary wheels. The Rudge wheels became a very, very expensive factory extra. If I tell you they were 6% of the cost of the car just to have Rudge wheels and hubs and brake drums and infrastructure, 6% of the total purchase price of the car. So they made about 1,300 and odd 300 SL Gullwings, between 130 and 135, depending on who you talk to, left the factory with these Rudge wheels. And these are now the holy grail of steel-bodied, as this one is, 300 SL Gullwings. And this car is actually one of the 130 odd that left the factory with those Rudge wheels. And they affect their value quite considerably. People will pay 10% extra for a car with Rudge wheels from new. Incredible, really. That equates to £100,000 or more, just because it's got those wheels on. Of course, lots of companies have jumped on the bandwagon and can sell you a set of replica-alike Rudge wheels along with all the bits that go behind, but you can never buy originality. And if the car, if it didn't leave the factory with those Rudge wheels, it doesn't get the 10% extra premium in price now. But they look great. They're actually heavier than the standard wheels, so they affect the unsprung weight, as it's called, of the car. But hey, they just look so cool. So yeah, the amusing part about these wheels is that Rudge Whitworth was a British company. They started off as an engineering company around the turn of the 20th century. And then they invented this knockoff spinner system, which became so successful on cars. Mercedes-Benz obviously had to pay royalties to the company that owned Rudge. They made them under license, and that company was Jaguar. Jaguar Cars owned Rudge license. So for every 300 SL they sold with Rudge wheels, Mercedes-Benz had to pay a royalty to Jaguar. How about that for a quirk of circumstances? So we'll move on. I'll explain a few bits and pieces about the car. The car's come in as a non-runner. It's been stood for some years, it's been dormant, it's in for recommissioning, so we have to start from ground zero with this car, drain the fuel out, flush the fuel system, bring the whole thing very carefully and lovingly back to life, and hopefully at the end of it, it will drive in anger as Mercedes-Benz intended it to. Well, one of the things that's been of absolute necessity to me over the years is having the accurate information to do the job as the cars come in. And I've been quite focused over the last 35 years, and 40 years actually, scary, of building up a library of workshop manuals and technical data. And the 300 SL is no exception. I've worked on had the privilege of working on quite a few of these over the years. This is an original factory workshop manual in English. This is from 1958, which is really incredibly useful. That's a spare parts list for every single part on the car with the part number. Some of them have been discontinued or superseded now, but it's still fantastically useful to have. And here is a reprint of the original handbook. And I've got to read something from this, which is absolutely hilarious, and it shows the 300 SL's background, really. The high speeds of model 300 SL will severely strain the tyres, and not all makes on the market will prove adequate to this strain. We therefore urgently recommend to consult our customer service stations, blah, blah, blah. If the vehicle is to be driven in a competition, it will have to be fitted with racing tyres. When did you last read that in a car manual? I can't imagine Mini putting something like that in their Cooper S handbook these days, really, or anybody else for that matter. But there it was in black and white in 1955. Well, this is where the money is, really. It looks beautiful up top, but the real heavy-duty, proper engineering is under here. This is the space frame chassis I was talking about, 25mm tubes. You can see just a glimpse of it here. The belly pans have been taken off this, the sort of aluminium shroud that covers the underneath of the car. And the space frame is clear to see. The front suspension, almost exactly off the Adenauer, apart from some drillings to lighten it. And here at the bottom of the engine is this tiny oil pickup area. It's not a sump. The actual oil tank is this here, huge thing, which fills the entire inner wing there. So the oil gets caught by a scavenge pump, as it's called, from the bottom of the engine, double quick time into this tank, and then the oil is pumped from this tank into the engine lubrication system. Now the important bit here, the business bit here, we've been working on the whole car, just bringing things back to life. I mean, these are a very, very labour-intensive car. The actual service schedule on them is every 2,500 miles. You've got to grease the front suspension and things like that. Change the oil and filter on the engine. Nowadays, people are advising that you change the oil more regularly than that, because the petrol actually mixes into the engine oil, and engine oil can stand just about anything apart from petrol getting in it and diluting it. It eats away at the bearing surfaces. But this is the heart of the machine. This is the injection pump. It's an adapted diesel unit. This is closer than ever to the fuel injection system that was used on the Messerschmitt Bf-109 fighters during the Second World War and the Heinkel HE-111s. Any aircraft that had the Daimler-Benz 601 engine in it was an inverted V12, that shape, and it had one of these 6-cylinder injection pumps on either side of it. And it's changed very little, really. Made by Bosch. It's a mechanical pump. It's driven from this quill shaft on the engine, and it's timed. You've got 6 injector pipes coming out, which are sequential with the firing order of the engine. But this injection pump fires directly into the cylinders. It's not into the inlet manifold, so it is the first ever petrol direct injection system. And they were way ahead of the curve on this. I mean, to my knowledge, and I'm prepared to be corrected on this, Mitsubishi were the first people to come out with gasoline direct injection, as they called it, in the 1990s, 40 years afterwards. And it's only in the 21st century that we have electronic direct injectors. So way ahead of its time. The point of it was, it came from the Second World War, because the German fighters in particular, which had to climb and obviously perform all sorts of high-powered maneuvers, needed power, and lots of it. And the German aircraft industry was relying on processed coal. That was their fuel. So they didn't have the fuel availability that the British did. So the British could soldier on with a fairly rudimentary fuel system on the Merlin engines in the Spitfires. The Germans didn't have that luxury, and one of the primary drivers for this system was to make sure that every cylinder got exactly the same amount of fuel. It sounds straightforward, but if you've got a carburettor with a great big long pipe going over the engine to the different cylinders, some get stronger mixture than others. So this ensures that every cylinder gets the same amount of fuel. And because the Germans were using lower quality fuel, they had problems with detonation and damage inside the engines on their fighters. So, you know, you're in the middle of a dogfight over the south coast of England in 1940 and in your Messerschmitt Bf-109, and all of a sudden a piston gets a hole in it, it's all over. You've got to parachute out. The plane's got to crash land. So the Germans spent a huge amount of time and money during the war to make a fuel system that would work the same as the British engines, but with lesser quality fuel, and they resorted to this technology to do it. Good news is Mercedes-Benz used this in the 1950s and made this engine as efficient as it was. I mean, it was turning out 215 brake horsepower in 1954 for the productionized version. That went up to 225 with a different camshaft that they introduced in 1956, just to give a bit more exhaust valve opening time. But other than that, the engine stayed the same, and that's the heart of this machine, and that fuel injection was the technological high point. Quite a job to get this set up properly and working. It's even got little things like leather diaphragms in it. Instead of more modern materials, they resorted to leather diaphragms because that was the materials that they had available at the time. So we've serviced this, we've flushed it out with new fuel, we've drained the fuel out of the tank, flushed the whole system out. So this is going to be ready to start shortly. But the whole car just is beautifully engineered. And the size of the exhaust pipe, this is a 3-litre engine. It's a huge exhaust pipe, really, just to get as much gas flow through it as possible and as much power. So we're going to look at the braking system next, because that obviously hasn't done any work for a number of years either. And we'll see what that brings. Well, for all its technology, one of the Achilles heels of this car is the braking system. And quite extraordinarily, Mercedes-Benz were way behind the curve on this. I mean, British sports cars had disc brakes on them in the early 1950s, so there was no excuse really. Mercedes-Benz we're still using drums. Beautiful piece of equipment. It's a cast aluminium drum with a cast iron insert. But the problem with drum brakes is, as they get warm, they get larger because they expand. And there's also a lot of material there to get hot. Once it does get hot, it can't diffuse it easily. But that's why disc brakes, as they get warmer, they expand. So they actually expand into the lining material. This is what's called a twin leading shoe setup. And what that means is that when you put your foot on the brake pedal, it pushes these pistons out, which pushes that end of the shoe out into the drum, and you get what's called a self-wrapping effect, where the drum actually pulls the shoe further in. It becomes a sort of help each other. And the reason for that is that it actually lightens the brake pedal. It means you have to have less pedal effort. And that's why on this car, the drum brakes, they had 2 generations of brake servo. And on the later disc brake cars, eventually in March 1961, Mercedes started specifying disc brakes on the last of these cars. You actually had to have a stronger servo because disc brakes have no self-wrapping effect. But we've freed all this off. It's in lovely condition. So I'm going to put this back together now, and then we'll give the car, we've done all the fluids, we've done all the checkovers, we've sorted everything out. So this car now should be good to go. So I'll put this back on and we'll take it out on the road and see how it performs. Well, another of the lovely features of this car is its original clockwork clock. And this has to be hand wound. So that's what I'm doing now. That's it, fully wound. Beautiful. One of the other beauties of this car is that the leather interior is, we believe, original from new in 1955, which is quite staggering. It's a particular grain and a particular type of leather that Mercedes used in period. It can be replicated and there are people who can do it, but it's believed to be the original interior, which is quite stunning really. This car also comes with fitted luggage, which is specially designed to fit in the back of the car, bearing in mind the fuel tank and the spare wheel take up most of the space in the boot, if not all of it. So it's got these beautiful 2-piece fitted luggage, which were an optional extra as well, and they're in this car too. Well, we've done everything we can. We've changed all the fluids, we've prepped everything, we've bled the fuel system out. There's no reason why it shouldn't start now, but you never know, you never can tell. Part of the starting procedure is to pull this actual cranking enrichment knob out. You only do that while you're literally cranking the engine, and then it should go. So here we go. Yes! Yes, bit coffee and spluttery, but we can adjust that, we can cope with that. Sounds sweet, fantastic oil pressure. Great, that's a result. We'll give it a run, see what it's like. Well, it's always interesting road testing a 7-figure car that's been inactive for some years for the first time. The expression, what could possibly go wrong, springs to mind. But yeah, we've checked and double checked and triple checked everything we can. So we're going to set forth. You can hear immediately how noisy that gearbox is. That's because the gears on this gearbox in Mercedes' quest to be as uncompromising as possible, and because of its race car origins, even though the gearbox has got synchro mesh on it, so you can change gear without double declutching as it's called, the gear teeth are actually machined at a very shallow angle. They're helical gears, so the teeth are slanted, but they're machined at 15 degrees, and it actually keeps the frictional losses of the gearbox down to a minimum. So in other words, as much power gets through the gearbox as it can to where it's needed, the rear wheels. And most production cars have 30-degree machine gears, which are quiet, but they do rob a few horsepower. So that's how committed Mercedes-Benz were to this project. But I mean, this car, obviously, if you're used to driving these things, this car is sort of driving itself, really. No seat belts, of course. Seat belts weren't around in 1955 in any degree on road cars, and but yeah, it's very happy. It's running beautifully on all 6 cylinders. I can just cruise along here. I'm doing less than 2,000 RPM, and the engine is pulling up cleanly, smoothly. The ride is very smooth. Brakes are pulling up square. We're in good shape, and all the gauges are working as they should. Even the clock is working now we've wound it up. It's a very happy place to be. On a very hot day, it can get very claustrophobic and very warm in here. You've got next to no insulation from the engine compartment, both thermally and acoustically, hence the fact it's quite noisy inside. But Mercedes-Benz didn't build this as a luxury car. This is a road legal racing car, and in fact they actually sold these cars for competition to sort of privateers, as they were called, who bought them and drove them to the racetrack, raced in them, and then drove home again, having won or hopefully not bent the car. It was still in one piece. Yeah, and this was in the days when you can do that. These days that is largely inconceivable, really. Well, yeah, it's warmed up now beautifully. Even the 15 litres of oil have warmed up. Huge amount of engine oil. Very few cars have that amount of engine oil, really. I think a Ferrari Daytona is 13.5, I think. Yeah, very few cars have 15 litres of engine oil. But now that it's all warm, let's just see if it does what it's supposed to do. So I'm going to drop it down and let's see how it goes. Oh yeah, well there's nothing wrong with the way that's pulling at all. It's just beautiful. Oil pressure's good and high, as it should be. Oh yeah, I'm very, very happy with that. Steering is surprisingly direct. I'm not moving the wheel very much at all for it to go around these bends. For a 1950s car, that is quite remarkable. They were so low geared, the steering at that time, really. This is very, very direct. Yeah, plenty of room. Let's just try it again, open it up. Oh, lovely. As I said earlier, these cars are so special. They're like a thoroughbred racing horse. You've really got to look after them in a very particular way. You can't leave anything to chance. And reading the handbook and the workshop manual, it's quite interesting to see the things that you have to do to these to keep them on top form. Mercedes talk about decarbonising the engine every 20,000 miles, every 30,000 kilometres. You have to take the cylinder head off and clean it out because it's been carbonised up. Even with that very high tech at the time direct injection system. So they're quite a maintenance intensive car, and these days it's actually said that you should change the oil every 1,000 miles in them, 1,000 miles or 1,600 kilometers, because they get contaminated with petrol. Yeah, quite a maintenance intensive car, but anything high tech needs to be particularly kept and particularly looked after. Well, I'm just going to drive it through these bends a little bit quickly. Obviously we've got to respect the car and its owner, but yeah, let's just try a little bit of that 300 SL cornering magic. This car just comes alive. You can just feel the racing car roots in this car. It just dances under you. Like that other iconic German high-performance car, the early Porsche 911. The last thing you want to do is back off the throttle halfway around a corner. Otherwise the back suspension starts getting very, very mixed up, and before you know it, you're going backwards through a hedge, which is no, not part of the road test we'll be doing today. But the car just literally, it just comes alive. To be someone in the 1950s to have the means and the wherewithal and the driving skill to drive one of these cars, just fantastic. I'll just try it again round these bends. Double D clutch down to second, power out. Oh yes. Beautiful. As I say, there's plenty of room around me here. I'm not loads of elbow room. Another virtue of this, the way the bodywork's designed. Quite a roomy car, really, considering it's an uncompromisingly aerodynamic shape. It wasn't built to be big, it was built to be as small as possible. This car is just, with the miles that I'm doing in it, the suspension is just freeing off, it's warming up, the whole thing is just really coming alive. Oh, now that fuel injection system's been cleaned out and set up, oh, it's just delightful. Well, one of the other the sort of Jekyll and Hyde personality of this car is that it is incredibly tractable. That means to say you can poodle around in it at next to no revs and next to no speed, and it's still quite happy. This isn't a sort of frenetic Italian V12. Not that I have anything against frenetic Italian V12s, but it will pull from nothing. I mean, I'm doing, if I change into fourth gear, I'm doing 18 miles an hour. And the engine is just very happy. It's just sat there, no coughing or spluttering, no sort of hesitation or fluffiness. It's just pulling, and just gently, it's off. I'm just touching the throttle there. When these injection systems are set up properly, they are just incredible. You know, whether it's tanking on or whether it's just pottering around like this, I'm literally just driving it below 30 miles an hour there with a whisker of throttle, doing between 1,000 and 1,500 RPM. And the engine's just very happy. Incredible feat of engineering. There aren't many cars in the 1950s that you could do that with, really, without sort of fouling their plugs up or even overheating or myriad problems, really. So yeah, just another fantastic sort of testament to the engineering that was at work here. Mercedes are not known for being behind the curve with technology, but one area on this car that they definitely were was the brakes. They feel okay, they pull up well and straight now that we've balanced them and set them up, but the drums very quickly, as I mentioned earlier, I'm not going to put it to the test, but they do fade under hard driving conditions. Mercedes, I don't know why they put off putting discs on this car till they did in '61. It just seems such a strange thing to do, really, but nevertheless, car's going great, pulling like a train. Well, there we are. Bit of a success story, fortunately. Hope you've enjoyed it. If you have, please like, please subscribe, please share, and we'll be back with something else very soon.